In this video here, we're going to take a look at using and understanding algorithms. Now, an algorithm is a finite sequence of step-by-step instructions that are carried out to solve a problem. And within this chapter here then, so this is chapter 1 on algorithms, we are going to learn of many different algorithms such as the bubble sort, quick sort, and also bin packing algorithms. And that's just for chapter 1, by the way. So for the other chapters here then within decision mathematics, you will learn of other different algorithms. So for example then, later on in the course, we'll learn about something called Dijkstra's algorithm. And basically what I'm just trying to kind of emphasize here is for decision mathematics, algorithms are really, really important, right? And I will go on to say that they kind of underpin a lot of decision mathematics. So please do learn this definition here. This is really, really important. I do often find that students can't really define an algorithm. So please learn this definition here, by the way. Okay. Now, you will have used algorithms throughout your life in a variety of different settings without really kind of realizing this. So for example, then how to add or multiply 2-digit numbers, or the recipe and ingredients for how to bake a cake. So I don't know about you, I'm not particularly good at baking, but if you have ever followed the recipe and ingredients for how to bake a cake, you have followed an algorithm. And we will often present the results of our algorithm as we work through it in the form of a trace table. Now, I do appreciate that I haven't presented a trace table on the screen here. We will see an example of that very, very shortly as we work through the practice question or the example for this video. But for now, just kind of take my word for it here. We use a trace table. We don't always use a trace table, but often that is the best way to present the results of our algorithm. And a trace table is used to record the values of each variable as the algorithm runs. Now, for exam questions on algorithms, if a trace table is required, this will be given to you in the question. So basically, all I'm trying to say here is don't worry about constructing your own trace table in an exam anyway. Like I said, if the exam question does require a trace table, it will always be given to you in the question. Okay? So to finish with here then, let's just work through an example together and demonstrate how we would use a trace table. So let's just get started here then with the one practice question for this video. Now what we're told here then is the steps below describe an algorithm. So as we can see here, then we've got step 1, step 2, step 3, so on and so on, all the way up to the very last step here, step 7. Now for the first part of this question, very typical of an exam question on algorithms here, all we want to do then is just simply implement this algorithm here, right? Now what you can also see here on the right is this table. And this table here is what we call a trace table. And as we mentioned in the introduction, if you have an exam question on algorithms and a trace table is required, that will always be given to you in the question, such as it is here, right? So not something that you do need to worry about. So to get us started here then, let's just make a note here that the trace table is for part A. Okay. So as always, then we start with step 1 here. So we start by letting n equal 1, a equal 1, and b equal 1. So nice and straightforward then, just input those 3 values. So n is 1, a is 1, and b is 1. Nice and straightforward. Now for step 2 then, it says print a and b. So sometimes with your trace table, you will have a print column. For this example here, we don't. So in that case then, what we do here, you're just going to write it underneath the trace table. So print a and b just means write down the value of a and b. So underneath my trace table here, I've got a and b. So a is 1 and b is also 1. So we get 1, 1 like that. And that's it. Step 2 complete. Now for step 3, we let c be equal to a plus b. So a is 1, b is 1. So 1 plus 1 is 2. Step 3 complete. Now for step 4, we print c. So again, all I do here is underneath my trace table is write down this value of c. So I've got 1, 1, and 2. Step 4 complete. Now for step 5 here, we let n be equal to n plus 1. So all that means here is as we go down the n column, this will just increase by 1. So my next n value here is 2. The new value of a here is equal to the old value of b. So my new value of a here is just this value of b. So that's just 1. And my new value of b here is the old value of c. So my new value of b here is this value of c here, which is 2. Step 5 complete. Now for step 6 then, if n is straight less than 5, we go back to step 3, which in this case, clearly 2 is straight less than 5. So in that case then, we just go back to step 3. And again, all we do here is we let c be equal to a plus b. So a plus b here, 1 plus 2 gives us 3. Okay, we then print c. So again, I go underneath my trace table here and just print this value of c. Perfect. Step 5, we just repeat this process again. So we let n be equal to n plus 1. So in other words, just increase this value of n by 1. So we get 3 there. The new value of a is the old value of b. So that's 2. And then the new value of b here is the old value of c. So that's 3. So that's step 5 complete. Moving on to step 6 here. If n is strictly less than 5, go back to step 3. So again, n here, which is 3, is clearly strictly less than 5. So all we do then is we just go back to step 3. As you can see, it is very methodical and hopefully quite intuitive to follow this algorithm. So going back to step 3 then, again, all we do here is we let c be equal to a plus b. So 2 plus 3 is 5. Step 4, we print c. So print this value of c here, which is 5. Okay. Step 5 then, again, we just repeat this process. We let n be equal to n plus 1. So increase the value of n by 1. A, so the new value of a here is the old value of b. So that's 3. And then the new value of b here is the old value of c. So that's 5 there. Perfect. Step 6, if n is strictly less than 5, we go back to step 3. So clearly here, 4 is strictly less than 5. So again, all we do here is we go back to step 3. And again, we just let c be equal to a plus b. So 3 plus 5 is 8 there. Okay. We then print c. So again, just write down the value of c here, which is 8. Step 5, we let n be equal to n plus 1. So we increase the value of n here by 1. So that's 5. The new value of a is the old value of b. So that's 5 there. And then the new value of b here is the old value of c. So that's just 8. Okay. For step 6, if n is strictly less than 5, we go to step 3. So here, n is not strictly less than 5. So in that case, then we move on to step 7 here for the first time, right? The very last step. And for step 7 then, if n is equal to 5, we stop. So clearly here, n is 5. So in that case, then the algorithm terminates. In other words, basically, the algorithm is complete. So that's part A done. That is the algorithm implemented and complete there. And then for the final part of this question here, part B. So for part B then, it just says describe the numbers produced by this algorithm. This is very typical again of an exam question here on algorithms, right? The first part, very common. It'll just ask you to perform or implement the algorithm. And then part B will ask you to describe or basically just explain what the algorithm is doing or producing. So if you look at these numbers here, hopefully you can recognize then that these numbers here are the Fibonacci numbers, right? Or the Fibonacci sequence. So the algorithm prints the Fibonacci sequence. Okay. And there we have it. You don't need to go into a massive amount of detail or anything like that. Just briefly explain what the algorithm produces. Okay. And there we have it then. So that gives us the solution here to the one practice question for this video. And that brings us to the end then of this video here on using and understanding algorithms.